Hi, everyone. I'm Saleema Amershi. I am a senior principal research manager at Microsoft Research, where I lead the Human AI Experiences team. I'm super excited to be back here. I went to undergrad and did my master's here, as Christina said. Worked with Alan Mackworth, gave me my first research assistantship position, where I learned about AI, and then I worked with Christina and I learned about human AI interaction, and been doing it ever since. So it's really nice to be back here. So today I'm going to talk about challenges in creating responsible and human-centered AI. And this is work that I've been doing for the last several years now at Microsoft in the responsible AI space. Microsoft has been very active in this space, and Ether is Microsoft's advisory council on AI ethics and engineering. And we have several working groups. I chair the Human AI Interaction and Collaboration Working Group. So we work on advising the company on how to create more fair, effective, reliable AI systems. So what I'm going to talk about today is some of the challenges that we've been and lessons that we've learned over the years. And there we go. Okay. So why are we so concerned about AI? I still get asked this a lot. And this question comes up a lot because, after all, AI is ubiquitous. It's everywhere. It's in our everyday applications and services, but it's also in a lot of our consequential services, like in the financial and healthcare industries. And while we're seeing AI really enhancing our capabilities and improving our lives in many ways, as it extends further into our society, we're also seeing more evidence of its potential to cause real harms. And for this, I'd say pick your headlines. Right, so here on the left, you see some facial recognition technology that was used to help blind and low vision people see sense people in their environment. Whereas on the right, you see similar technology used in an undisclosed surveillance system in New York to find and harass a Black Lives Matter protester named Derek Ingram that you see here. And this problem of AI potentially causing harm goes well beyond these sort of nefarious use cases. In fact, it's very easy for things to go wrong. So some of you might recall Microsoft Tay, which came out a few years ago. And it's a seemingly benign technology that was released. But within 24 hours of its release, it turned from this friendly chatbot on Twitter to this sexist genocidal maniac. And here, Tay was actually doing what it was designed to do. It was designed to interact with people and learn from people, except what we didn't anticipate was how much of the data that it was going to collect and people it was going to interact with were trolls. And so it was shut down soon after that. And so it's this potential for harm that is really causing society to start demanding change and accountability. So here you see, this is an image from of attorneys for Facebook, Twitter, and Google testifying at a Senate Intelligence Hearing Committee about what they were doing to prevent Russian-led interference in the 2016 presidential elections. So responsible AI is really a movement that is driving change in the industry to ensure that our AI systems are safe, fair, reliable, and trustworthy. And now many of these demands are starting to get codified into laws. So here are just some of the forthcoming responsible AI regulations, guidelines, and standards that are starting to come out across the world. There's some, I believe, in Canada as well. And this is great. We need this. But what we're seeing is that the industry is not quite ready for these. So this is a survey from just a couple years ago of 2,700 executives from organizations around the world that were building or using AI systems or deploying AI systems. And what you can see here is that there's this big gap between concerns about AI risks and failures and how prepared these organizations believe they were to address those. So the blue dots on the far right are how concerned these organizations are, while the teal dots on the left are how prepared they believe they are. So there's this big gap. And the question is why? Why is this so difficult? And what can we do about it? And so this is what I'm going to talk about today. First, I'm going to deep dive into some of the forthcoming responsible AI regulations. And then I'll talk about the key technical and cultural challenges that we're facing in implementing them. Is this like
Maybe
in the
if you
way?
can
Yeah.
minimize that would be great. Yeah. Yeah, perfect.
Yeah. Yeah.
And
Great.
maybe you can remove that pop-up by clicking this.
If you can turn on the camera. So,
Let me turn on the camera. Okay. Huh?
we can see you.
Okay. Okay, so let's talk about some of the challenges. And then I'll talk about why a human-centered approach is going to be critical to address these challenges. And I'll talk about some of the new tools and methods that I believe that we need in this space to help. Okay, so first I'm going to dive into these regulations. So there are hundreds of these coming out across the world, but today I'm mostly going to focus on the European Commission's AI Act. It's one of the most comprehensive and well-known set of regulations that are coming out. And it's important to note that I'm going to be showing you quotes from this, but these are still, many of these regulations are still have open feedback periods. So what I show you might not be actually what gets codified into law, but you can actually provide feedback to a lot of these regulations right now. I'm also going to be talking about some of these regulations in the context of building an AI system end to end. So this is just a very simplified conceptual view of like what it takes to build an AI system. And this is from, we did a study of people across the company at Microsoft a couple of years ago, interviewed practitioners, and then did a large scale study just to understand like what are the key phases of building an AI system, from conception, so when you're defining requirements, to collecting data, designing your model, architecture, features, training models, evaluating them, integrating and deploying. So I'm going to talk about the regulations in the context of this. Okay, so let's dive in. Okay. Anticipating risks. One of the first requirements in responsible AI regulations in the EU Act in particular is to anticipate risks. And the guidance here is to think about this before you even start and throughout the development process. So here you see Title 3, Article 9, which says that developers should create a risk management system that shall consist of a continuous iterative process running through the entire life cycle of an AI system, including for the identification and analysis of known and foreseeable risks. Now, anticipating risks is important because, you know, we saw in my earlier examples that it's very easy for things to go wrong. And there's technical challenges in doing this because it can be hard to foresee what how AIs can go wrong because they're unpredictable, they behave under operate under uncertainty and are probabilistic. But what I think is even more challenging is overcoming some of the cultural challenges in helping people think about risks upfront. And this stems from a lot of misguided perceptions about what is even an AI error or failure. So we actually did a study a few years ago where we asked AI practitioners what their perceptions were of responsible AI incidents that we were starting to hear about in the news. And we heard some interesting and sometimes alarming things. So for example, when we asked creators about what they thought about issues like Amazon's recruiting tool here, like you see here, that was showed a bias against women, a common sentiment that we heard is what we call the "this is reality" argument. And it goes something like this: there are a lot of people who do not see a problem with this. The attitude is that this is actually what reality looks like. Now, of course, this is a dangerous sentiment because even if there is a gender imbalance in some fields like engineering and computer science, AI models and all models, by definition, simplify the world. And that's because it's difficult, if not impossible, to fully computationally capture everything about the real world. So for example, if we dive into this AI-assisted hiring scenario, if your goal is to predict if someone's going to be a good person to hire or not, how you represent these people is really important to your algorithm. So in this case, maybe you only have access to two types of information: the years of higher education a person has had and maybe their previous salary. Here, of course, you're missing a ton of information about what makes a person a good candidate, their ability to collaborate or their life experiences, which you just can't capture very well computationally. But even your choice the things that you can capture computationally can encode biases themselves. So it's known now that previous salary has encoded biases against women. So the point is that this is not reality, right? It's a simplification. And so it's important to challenge this argument that you hear about, because it's this type of thinking that excuses the industry from acknowledging and then taking steps to address consequences of these limitations. Another argument that we heard a lot is what we call the "this is just math" argument, which goes like this: at the end of the day, the data is just going to be aggregated and shown. It is not going to be wrong what they're going to see. It is still going to be right. We are not expressing opinions or anything. Now here, the idea that because it's math, it might be right is again not true, and it's dangerous because it lends a false sense of credibility to potentially harmful results. So again, going back to our model here, what AI algorithms often try to do is learn to generalize to new data while optimizing some objective functions. So maybe minimizing loss or errors on a training set. So what that means is that what it's doing is like your algorithm might try this model first, which has 8 errors. And then it might try this model, which has 7 errors, and go with this one because it's the minimum number of errors it can achieve. So the point here is that AIs by design make mistakes. They're designed to do the best under the circumstances. And because we can't computationally capture everything we need to make these types of predictions, there are going to be some mistakes. So anticipating risks, one of the first things you need to do, according to these regulations, really requires shifting the mindsets of the people building these AI systems to acknowledge the risks and take some action to address them. So now say you were trying to build an AI system, you've thought about the risks. The next thing you might do is try to collect some data. And of course, regulations have a lot to say about data because AI systems are often a product of data and an algorithm. And here, what the AI Act says is, in order to be responsible, training, validation, and testing data shall be relevant, representative, free of errors, and complete. Now, again, it's well-intentioned, but as we were already seeing, this is impossible. And I'd actually argue that it would be better if we as a community acknowledge that the data that we have and the models will have biases and limitations, because if we acknowledge it, then we can actually take steps to minimize consequences of these. So, while we can't be error-free and complete, we can have more appropriate data and less appropriate data. And there's technical challenges in doing this as well. So, for example, data is just notoriously messy. And depending on who you ask, it can take practitioners anywhere from 45% to 80% to almost 100% of their time to collect data, prepare it, process it. And some of these, likely exaggerations, but it is true that the data and wrangling the data is incredibly challenging and takes a ton of time. It's expensive, it's error prone, and doing data collection really requires a bunch of other tasks. You collect, you maybe merge the data, prepare it, process it, annotate it. So within just this step, there's a bunch of things you have to do. And each of these is difficult in its own right. So for example, annotation. So a lot of times with supervised machine learning, you need annotated data, so data that's labeled, and often those labels come from people. But people often disagree when labeling. So you see this on subjective tasks. So, sentiment analysis, is this a positive sentiment or negative? But we also see reasonable people disagreeing on seemingly objective tasks. Is this a cat? The first one is probably cat, but is a picture of a cat? Is a cartoon cat a cat? Reasonable people will disagree. And in fact, we actually did a study several years ago where we had 9 machine learning experts label some data for seemingly objective tasks. And we found that they were only about 80% consistent with themselves on labeling the exact set of data over 2 sessions. And 6 out of 9 of them, the labels changed significantly. Okay, so this is just one of the steps in this process. So it's challenging and expensive and error prone. Okay, so now say you're building an AI system, you've thought about risks, tried to collect appropriate data. You might then train your model. Then the next thing that AI asks you to do is measure how well your system is doing. So here the AI Act says that prior to placing on the market or putting into service, testing shall be made against preliminary defined metrics to achieve an appropriate level of accuracy. Now, testing, is important for every system, especially those that can have a real impact on people's lives. And in fact, in many safety critical industries like transportation and medicine, we have standards in place for what's defined as acceptable performance levels. But in contrast, we don't have these for AI. And I'd argue that it doesn't necessarily make sense to create prescriptive standards at the model level. So this means performance is very context dependent and application dependent. So, if you go back to the facial recognition example I gave you earlier, in that case, if you're using a facial recognition technology for police surveillance, false positives that might be much worse than false negatives. Whereas if you're using it for assistive technology to sense people in your environment, then maybe a false negative is much worse than a false positive. So appropriate level of accuracy is entirely context dependent. So doing this is still not well defined. Another issue we have in terms of measurement and evaluation in the community is that there's this deep-rooted culture in the industry around benchmark data sets and metrics. So like what you see in these types of Kaggle competitions, for example. And benchmark data sets have actually led to rapid advancements in AI. And it's really helped accelerate the field, and because it allows for apples to apples comparisons. But bad things can happen when you over-optimize for them or use them inappropriately. So here, for example, this was an incident where a Palestinian man was arrested when his Good Morning Post in Arabic was translated to attack them in Hebrew. And this was using Facebook's AI-based translation feature. And we know from their own communications that at least one of the ways they were evaluating their algorithms was using a metric called BLUE, which is an industry standard. And it essentially just counts the number of words that are shared across sentences without considering their meaning. Of course, though, in this context, in this application, preserving meaning was probably the most important thing to optimize for. So, while we don't know if the incident was entirely caused by this metric, and oftentimes companies use a variety of metrics, but over-optimizing for metrics that don't represent what people need and value is one of the reasons why AI sometimes gets a bad rap. In fact, this was a study that came out just recently, and this was a survey of natural language generation papers in the academic community. And you can see here's the number of citations on the y-axis over the years. And from this, you can see that despite major criticisms, so these are the dashed lines, the vertical dashed lines here, of which are major criticisms of metrics like BLUE for not capturing reality well, the number of citations for these types of metrics has just skyrocketed. And this is not about BLUE. It's about optimizing for things that, while it might be efficient to compute, and we can do these quick comparisons, when they're used, in deployment settings and when they don't actually reflect what people need and value, bad things can happen. So I think what we need to do in the community is adopt more rigorous practices, validate that our metrics are meaningful in the context of use. Okay. So ensuring appropriate performance is something we need to do, but it's difficult. So now say you've thought thought about risk, collected appropriate data, evaluated your system. The next requirement in the EU AI Act is to mitigate risks. So according to the Act, it says, in identifying the most appropriate risk management measures, the following should be ensured: elimination or reduction of risk as far as possible through adequate design and development. So why is this hard? We've actually made a lot of investments in tools for model evaluation in the community. So we have a lot of tools for like visualizing performance, disaggregating performance, trying to explaining errors. But so these are great, but actually going back and trying to fix errors that you might identify using these methods is still very much an art. Some of these tools can like give you suggestions about, parameters you might want to optimize for, or how to perturb features. Some can go back to your data and suggest reweighting mechanisms, but few of these can actually take you back to the decisions that you made in collecting the data in the first place, or the decisions you made in defining your requirements. And so actually going back to mitigate errors that you find during these evaluation steps is still very difficult. Okay. So now, say you've done all your due diligence, done all, measured your performance, tried to mitigate some risks. You're never going to get rid of all the errors, as we've talked about, because errors are inherent. But maybe that's okay, because once you deploy, you're going to have a human in the loop, right? And I'm actually happy that a lot of the regulations and standards that are coming out talk about some of the challenges of having people in the loop, and acknowledge that people are often in the loop. So here you see that the EU AI Act says that you need to ensure effective human oversight, which includes having people fully understand capacities and limitations of these systems, having them remain aware of things like over-reliance, having them be able to correctly interpret or override or intervene when the AI goes wrong. So this is great, but the problem is that people are actually really bad at oversight. So this is a real example, a real incident where an Uber driver blindly followed their navigation app down some stairs. And it's not an isolated incident. It's this actually a real phenomenon that it used to be called death by GPS because it happened a lot when GPS systems came out. But it's this idea of people often over rely on automation systems. And that's due to a lot of cognitive biases like automation bias, automation complacency, having incorrect mental models, etc. What makes this worse is that a lot of what we've tried in the community to prevent this can make it worse. So, for example, there's been studies that show that having a more accurate model can actually make people more reliant and make the human AI team actually perform worse in the end. Other studies have shown that if you provide an explanation, just having like an explanation there gives an AI system a sense of credibility, and then again, people will over rely and trust it more. So it actually makes people worse at oversight. So simply putting a human in the loop is not enough to compensate for these failures. So these responsible AI regulations are coming. Actually implementing them is still challenging, and there's a lot to do to overcome both the technical and the cultural challenges here. Fortunately, I do think we have made progress, and I think there are things that we can do, which is what I'll talk about next. Okay. So one of the things you might have noticed, I haven't talked a lot about AI algorithms and models here. And that's because not that it's not important, of course, but I'd argue that a lot of responsible AI comes down to making good decisions. So that means making decisions that reflect what people actually need and want from their AI systems. So like anticipating risks is about thinking about your end users and their context of use and understanding what might happen if things go wrong, collecting data, and ensuring appropriate performance is again thinking about the context of use and making decisions on what to capture and how to measure there. Fortunately, we have a whole field of research dedicated to understanding people and their needs. And it's called human-centered design. And now there's many definitions of human-centeredness that people use. I really like the IDEO's definition of human-centered design as a creative approach to solving people's problems that begins with identifying their needs and ends with creating solutions that meet their needs. So given that, we have like decades of learnings here, a reasonable question then is, why can't we just use human-centered design to build responsible AI? I would say, yes, we can, but we need new tools and methods, because a lot of the traditional tools and methods that we have fall short when it comes to AI. So this is a quote from one of the many studies that we do in the space, which I think sums it up well. This is from a designer saying that, AI is the most ambiguous space I've ever worked in my years of working in design. We're literally making this up every day as we go along because there aren't really any rules and we don't have a lot of the tools. Okay, so digging into this a little bit more, human-centered design says first we need to understand people and their context of use, and then use that to make the decisions throughout for all the pieces of an AI system. So that includes the interface, the models, the data, infrastructure. Now, some of the methods that we have for human-centered design to understand people, are things like observational studies, interviews with people, empathizing with people. Like, we have these techniques to do this. But what we've seen is that when it comes to AI, sometimes what people want and need isn't always aligned with what's possible with AI technologies. So looking at this in the context of a study we did a few years ago, here we were trying to create an intelligent writing assistant. And so we started with our human-centered design approach. We brought writers in to the lab, interviewed them, observed them writing. And some of the ideas that came out of this were like some technology that could make this better, or change the tone of this, or ask questions like, is this coherent? And it turns out that, what writers actually wanted was well beyond the capabilities of the state of the art at the time. Now, things are changing very rapidly, which is a whole nother conversation. But at the time, this wasn't possible. And what was possible was things like being able to classify a short piece of text, or auto-completion, which is helpful, but is not going to fundamentally change the writing process. This is not what writers were asking for. And so one of the AI researchers on our team said it best, saying, "You are really good at designing things we cannot build. We are really good at making things users don't want." So what we ended up doing here was creating a boundary object. So boundary object is just a tool, an artifact that can help scaffold conversations across communities or disciplines. And so this was very simple. It was just kind of like a Jupyter notebook. It looked like this. It was essentially what it was is it allowed it's a Jupyter style notebook where we could take it to the lab and have writers write as they would. As they were writing, they could make requests about what they would want, some imagined function. They could actually write it down there. They could also, highlight things, select pieces of text, and then ask for something like, is this too formal? We actually then were able to take this artifact back to the AI researchers, and it gave context. It gave context about what data was available to work with and what people were asking for. And without actually having the text and like data to look at, the conversations used to be like, we need 10 more years to make that happen. But with this artifact, we were able to have much more concrete conversations to figure out what was possible. Like we'd go back to an NLP researcher and they'd say that, well, this sentence is too mangled. But it also allowed for cross-disciplinary ideation, right? So then they could say something like, we might be able to leverage this other available data to make this happen. And so more ideas would come out, and then we would go back to the lab and give some possibilities here to the next set of writers. So the point is, this is not the tool, this is not the thing we were trying to create. This was just a mechanism and a boundary object to allow for collaboration between these disciplines. User researchers could use it as they normally would, and then the AI folks could use it to help build AI systems. And so where we ended up with, in this work was very different than where we started. We wanted to have a tool that could make this better, but instead we ended up with a bot that you could ask more targeted questions, like how does this compare to a target venue, or am I writing too formally here? So I think there's a lot of opportunities that we have to come up with these types of tools to facilitate collaboration across disciplines for AI. Okay, how are we doing on time?
5 minutes.
5 minutes? Okay, perfect. So once you have an idea of what to build, the next thing you want to do in human-centered design is use that and think about how to build it. And that means starting to think about how to design and develop a system to support the needs that you identified. So in the design community, we of course have decades of knowledge about how to design intuitive and fluid user experiences with traditional computing systems. And these are just some familiar examples for guiding or creating effective experiences. But AI systems are fundamentally different than traditional computing systems. And in fact, a lot of what makes AI so powerful is also what makes them really hard to design for. So for example, there's this principle in design of the consistency principle, which says that we should build our experiences to be consistent and predictable because it saves people time and reduces errors. But AI systems are just inherently inconsistent. So for example, AI systems are probabilistic, they can change and adapt over time. So that means that they may react differently to the same input, even after a model update, or they could behave differently in even subtly different contexts. So for example, speech recognition systems can fail sometimes to just ambient noise or noise in the environment that you as a user aren't perceiving, but it's making the system behave differently in seemingly similar situations. Another example is error prevention. In design, careful design should prevent errors from happening in the first place. But again, as we talked about, errors are inherent in AI systems. They're often unavoidable. This can lead to, humorous failures, like when your Alexa puts babies in your shopping cart. To obviously more harmful scenarios where people, have been injured or economically impacted. So this is a case of a semi-autonomous vehicle failing to detect a fire truck that was stopped on the road, and the driver wasn't able to intervene in time. So we need new guidance and best practices for AI systems. And we tried to do something around this a few years ago with the guidelines for human AI interaction. We did this by synthesizing work in the field for the last 20 years. There's been a lot of work on improving these types of systems. And so this was to synthesize and validate them on a variety of AI products. But these are intended to be like the basics and broadly applicable guidance. But AI is still advancing rapidly. And we expect that these are going to need to evolve for like these new foundation models or these new things that are coming up. And you may need additional guidance for specific scenarios. But this was an attempt to sort of help with the designing of AI things. Okay, so can we use human-centered design for creating responsible AI? I'd say yes, but we need new methods, we need new tools and guidance. Boundary objects I've talked about. There's a lot of opportunity, I think, for rapid prototyping tools, methods to simulate AI behaviors early on so you can test them, guidance. There's just a lot that can be done here. That can really help. And just the last thing I wanted to say is that if you're thinking about creating new tools, I would strongly encourage you to think about how the tools will fit into the end-to-end process of building an AI system. Which means that, I've been using this conceptual view of building an AI system for the purpose of this talk, but it's important to realize that the actual process of building an AI system is much more complicated. This is an illustration from Kate Crawford and Vladimir Joler. It's called The Anatomy of AI. And it documents the process of creating, this was the Amazon ecosystem. So the real end-to-end process of all the steps involved in doing this. And the actual design here was shown, I think, at the London Art Museum, and it was like 6 feet high and 15 feet wide. And I just wanted to show this because, you know, it emphasizes that building an AI system isn't always about, it's not even about building a single model. It's often multiple models being stitched together with traditional code, and that work can span many tools, many teams, many people. So if you think about these steps in isolation, that can often lead to tools that are just too heavyweight to be adopted. So, and I'm guilty of this myself. So like we did some work a while back on this is a tool called Model Tracker. It was an error analysis tool. I loved it. It was beautiful. You know, it like allowed you to explore your data and see what was happening. And it was used in systems where the whole pipeline was contained in that system. So these are 2 interactive machine learning systems we had at Microsoft, language understanding system, where Model Tracker was built in. So there it worked, right? Because all the steps in that, you know, giant design, the anatomy of AI piece was like contained in this system. But when the work to build an AI system is spread across teams and people, this is where, you know, error analysis happens. If you have a heavyweight tool, it's very difficult to have it be impactful. And especially if you want to do responsible AI and iterate and make sure your system is evaluated rigorously, then you actually have to go through this process many times. And so it makes it even more challenging. So I think there's a lot of work that can be done on tools, but tools that can help streamline this process. So many open challenges and opportunities. So with that, I will summarize. Today I talked about responsible AI, which is a movement that is driving change in how we build our AI systems. Implementing these forthcoming regulations is going to require overcoming a lot of technical and cultural challenges. I think a human-centered approach will be critical, but we need more work in tools and methods for doing this. And with that, I can take questions.
Questions, if possible, we'd like people to come and line up here because it would be easier for those who are on Zoom to hear what you're saying. So if you don't mind, you know, lining up here, and or if you feel subconscious about doing that, you can ask your question and I can't repeat it. But this is a very friendly venue. So okay. Any question? And we'll try to prioritize the first two people here, and then we'll see if there are questions from the crowd on Zoom. Yeah.
So
You're not shy.
I'm not shy. So you're talking about design and making decisions. Hi.
Hi.
And you say there's just models, pretend there's models and data, but people who do decision making want to have utilities and preferences. You didn't talk about those as though they don't exist in making decisions about the world. We don't have to worry about what the values are, what people's utilities are, and you're not trying to. So where does that fit into this, and how much are people taking that into account?
A lot so a lot of the companies now, for example, have stated value systems when it comes to responsible AI. So like they should be, like Microsoft, for example, has these principles of fairness, transparency, reliability, and many companies do. And that in essence is talks about values, but in actually implementing them in practice, there's trade-offs. We had I can share a paper we did in the FACT conference just recently, where we had people trade off values like fairness and privacy, for example, is a common one, where if you want to, achieve fairness, sometimes that means, collecting data that reveals information about, your demographic information. And so there's trade-offs that need to be made, and that definitely comes into the decision-making process. But at this point, there's no real guidance on how to make those trade-offs. So that means that people who are making them are deciding on their own.
What about people who have different my preferences might be different
Yeah.
to yours, and how much
Yeah,
you want to take into that, so if you're interacting with me, maybe I have other people might have quite different preferences. So
Yeah.
how do we?
that is a great question. I think there's like a lot of room for personalization still, you know, like with these systems that can learn about preferences, but like, yeah, that's an open question. Yeah.
So a really great talk,
Thank
first of all. I was curious about your flowchart diagram that
Mhm.
you made. And I feel like one thing in the end that you're kind of deploying,
Yeah.
that is missing, is like educating people about AI
Mhm.
technologies.
Mhm.
Because when you're deploying it, and if people are not aware of what's going within those, they wouldn't give you the feedback and they wouldn't be able to handle the system very well.
Yep.
And also this comes in the loop when you're talking about human-centered design
Mhm.
and you're asking for people's needs. So I'm curious, like, is there something that we as researchers need to do to educate people and like have that in this model integrated? Like whenever we are deploying technologies, like they're aware what's going
Yeah.
here, and then they can provide you the feedback that you need to improve that technology.
Yes. So yes, all of that, there's definitely, we see when deploying these systems that a lot of people have sometimes unrealistic expectations of AI systems because of how they're portrayed in the media or how they're marketed, and that can really impact how much they rely on these things. So it's a mix of their expectations going in, their experience with the system. If you give them information about like how well this thing might perform, then they can adjust their expectations, but then after they interact with them, it might change their mental models. And so there's a whole bunch of work to figure out how to help people have the right expectations of systems. And it's not, and their people's mental models and AI systems both are dynamic, right? So AIs will change and can, you know, update over time, but so can people. And so like, it's difficult to make sure, I feel like there's a lot of work to be done to, you know, make sure people are calibrated as to how well an AI system is doing. So I think there's like education is part of it, but there's also, I think, room for like tooling and like interactive support to help people if these systems change. I'd also say in terms of education, I think there's a ton of work we can do, like educating like folks building these types of systems. You know, often like, you know, when you're learning about AI algorithms in the universities, like, you know, you might be given a data set to work with, and that, you know, prevents you from learning about the pain, like feeling the pain and suffering of like collecting data and then seeing it being used and deployed and seeing it all break down, right? And I think there's a lot of room to have the educating the folks building this upfront. Yeah, I think, yeah.
I'll choose. Okay, you go first.
Thank you, it's amazing. What happens, because I feel like here UBC and Microsoft, we're aware of this, but then how about really fast OpenAI Stable Diffusion
Mhm.
that was rolled out, and it's like borderline magic.
Yeah.
But how is it built? It's I feel like they failed to, and it's happening really fast.
Yeah.
Yeah, so like that idea.
Yeah. Yeah, I mean, I was just joking that like the steps that I showed, you know, almost like they might not reflect like just in the last like 6 months, like how fast things are changing. Now you have these foundation models and like a lot of, you know, you might start with a giant model and then maybe do some fine tuning and prompt engineering. So like it's things are changing and I don't have good answers for this. Like, I don't think like anybody really understands how those large models like really work, and it does feel like magic. Like I've used the technologies myself and like I've been working in this space for a long time and like I'm pretty skeptical about like what you can do, but like some of these like new tools are just like mind-blowing. So I don't know, it's changing things. And yeah, it's just changing things. I think there's just like a lot of interesting questions and I don't have an answer.
Yes, thank you. As you know, I'm a fan of your work and your 7-step model. And the tying to the European AI bill from last year, the proposed one is very nice. You make some good points with it. I wonder also if you could tie to last month's US announcement of the blueprint for the AI Bill of Rights.
Yeah.
That would give a new set of requirements of safety and efficacy that would, I think, strengthen the arguments for what you're doing. So the follow-on question, the tie-in question is, how well has your 7-step method been accepted, adopted, and applied in Microsoft? And did it make a difference?
My 7-step method, you mean like this, the process
This is the
overview?
process model, right?
So that wasn't like a prescriptive, it was about what was happening. So it wasn't just meant to change how things are happening. It was meant to explain how things are happening. So I wouldn't say it wasn't designed for that. I think the guidelines are one of the tools that we did create as a part of, it was one of the work that we did early on in Ether. And that was to help designers who were building these AI systems to get up to speed about what are sort of like the challenges of like expectation setting. So like that's something in the guidelines. Dealing with errors. A lot of times we heard that, people thought these systems were magic, like people building them, like they felt like just, it's not going to be wrong. Like they don't make mistakes, but they do. And like, we know that they make these types of mistakes, these types of mistakes. So that has helped. I think that's kind of goes to education, but there was just a ton of work that like, once we had those, then it helped people understand like what to do, but not how to do it. And so how you actually like take that and actually build it into a system is hard because a lot of the guidance doesn't just affect the UI layer. So you can't just happen at the end. A lot of the times, like if you want to have a system that has an explanation, for example, you need a model that can provide one. And often if those decisions are made early on, it's very hard to change at the end. And so this is where I think there's room for like having the more human-centered approach where you have those decisions being made upfront based on understanding and talking to people.
Well, so I'll just go further. I mean, you're looking at ways to assess the safety and efficacy of AI.
Yeah.
Can you tell me about the safety and efficacy of the 7-step model?
So I don't know if I understand the question because the 7-step model doesn't encode like guidance on how to make systems safe, right? It talks about like, here are the sort of standard steps that go into making a system. I think the things like the regulations cover a lot of those steps. So I think they're intended, like, I think if you think about the regulations, in fact, the regulations, when like, at least the ones like that I've seen like in the EU AI Act, they're not framed in terms of that 7-step model. I think that 7-step model is good for when people try to understand, when do I need to be thinking about this thing that you're telling me to do? Well, you think about it at the point where you're collecting your data, or you think about it when you've trained and you want to evaluate. So I think it can help like orient practitioners to where they need to consider these things, but that's still a struggle when you have agile methods and
Sorry, I'm gonna say that because we're past one, so let's say that the seminar is officially closed. If people want to leave, they should feel free to do that without feeling guilty. We can stay a few more minutes for those who have more questions, but otherwise people who need to leave can do that at this point. So should we, okay, maybe a little one.
So, US regulations or fuel efficiency or safety for cars have demonstrably increased safety and fuel efficiency. How will we know if these regulations or your process improve the qualities of the AI system?
That is a great question. I think there's a lot of room for creating metrics for responsible AI. I mean, it's hard to like, we've thought about this. In fact, like some of the things we've been working on recently is like, how do we measure automatically when people are over relying or, following an AI system when it's wrong? And that's like not something that's easy to track because you don't know if people would have done it themselves. So I think that, if we were able to measure that type of thing, then we could see if like, actually considering these things made that, people better at appropriate reliance. So I think there's a lot that can be done in the metrics space to measure these, but I think, yeah, I think it's a good question.
Thank
you know.
And I think Alan had a question to
Okay.
So I think the EU Act has 3 levels of risk, like high risk,
Yeah.
medium risk, and low risk system.
Yeah.
Which has to be factored in here.
Mhm.
And there, to look at the risk, we have to look at the cost of the likelihood of false positives, the
Mhm.
likelihood of false negatives,
Mm-hmm.
the cost of false positives.
Yeah.
cost of-
Mm-hmm.
You have to factor all of that in. Is that something that you look at responsible?
Yeah, that's something we think about a lot, Eric Corvitz, like he started Ether, the company, and he thinks a lot about the costs and of these types of things. And yes, I think this is, Microsoft released the responsible AI standard. That's our internal standard, but we've released it externally for people to see. And part of what we have teams doing now is an impact assessment upfront. So we ask them to try to think of different stakeholders that might be affected by a system, different outcomes of using the system. And that's when we have guidance and tutorials and educational material to help them think through these types of costs. And yes, I think, right now we're focusing a lot on like high risk systems like the EU Act. But, I think it's easy for even like seemingly benign systems like to hurt people. So I do think that this is going to be something that we want to think about for all of our AI systems, and helping people streamline that, I think, is important.
I think there is one question from the online.
Yes, it's a question from Francis Quebecia. He's saying, how can AI design be revised to be more human-centered to mitigate risk? Francis, are you there? If you can add a little bit more context regarding the question, feel free to do so. If not, we can just get the answer. I think we can move on.
Okay. So how can design, how can we, can you state it again? Sorry.
How can AI design be revised to be more human-centered to mitigate risk?
Yeah, I think, so one is sort of the education about some of the ways that AI can go wrong and things that are common. But I think things like early prototyping tools. So a lot of, in design, you have a lot of tools to do like low fidelity prototyping to get feedback from people early. And when you do that with AI, it's often we see that the sort of ideal scenarios tested early on, because it's hard to simulate like how an AI will fail and how, when it fails in certain ways, how that can contribute over time to people's perceptions. And so I think there's a lot of room for creating tools for like simulating, like Wizard of Oz type tools, or tools for like having designers be able to play around with different ways an AI might behave once fully developed. So if you do that early on, then you can influence the models that get built.
I have a follow-up question. Could be okay?
Yeah.
Yeah, and it's relevant to previous question about education. So I noticed you mentioned this group of people, so design experts and also the AI experts.
Yeah.
And they might be two different communities that can, at least in academic, be on the communities like high versus yours.
Yeah.
Question is, how do you think the educational institution should respond to meet the needs of the corporate, so they can actually work on all those jobs that you have listed here for responsible AI? Do you think a good designer and good expert, AI expert can meet and they can address it, or there's some cross-disciplinary pollination of ideas? What do you think?
Yeah, this is a great question. I think, I would love like more cross-disciplinary pollination, like in when you're learning about this. Like I would love like to have more courses for responsible AI, having folks think about ethical issues. And, you know, I think it's not reasonable to have like design, like have people who are like proficient in design, learn everything about AI and vice versa. But I think there's learning even the language, like what, you know, about for designers to learn like terminology about model building, that it can go a long way with in collaboration. But similarly for machine learning folks, you know, to learn some of the, you know, what does human centeredness mean? You know, like there's actual methods that we have for doing these things. I think like learning about each other's disciplines can help with that along with tools.
Awesome. I think DFP should talk to Kaida.
Yes, we can start. That's a good idea. Excellent. Thank you so much
Thank
for the
you.
wonderful session.